So in Algebra 1, we talked about simplest radical form. Now, some of you may or may not remember it very well because it's something that we talked about when we were dealing with real numbers. It wasn't the main focus of our course. And so today we're going to bring it back as a review topic. And the reason why is because we use this when we study trigonometry. So if you remember with square roots, there are certain square roots, and in the warm up we kind of reviewed these that are perfect squares. That means when we take the square root, we get an integer number, a positive integer, a whole number, and so those would be things like um, 1, 4, 9, um, 16, 25, 36, 49, 64, um, 81, 100. And it goes on, but if you just have these in your mind, you're good enough, because for what we're going to do, we're not going to need anything bigger than that. Of course, they continue 121, 144, 144 is 12 squared, 169 is 13, 196, that's 14, 15 is 225, 256, and 289. And so these other ones you should be aware of, but they're not they're not what we need today. So why are these important? Well, because we use simplest radical form when we're trying to simplify square roots that are not perfect squares. And as you can see, most numbers are not perfect squares, and they have they're irrational numbers when we take the square root. So, for example, if I were looking at the square root of 10, that's not one of these numbers. 10 is not in here. So I would know that the square root of 10, well, that's a little bit bigger than 9. It's going to be close to the square root of 9, which is a little bit bigger than 3, like 3.1, something like that. And in that situation, the square root of 10 would not simplify any further. But there are some square roots. For example, if I were looking at the square root of 50, which I could continue to simplify. And so I would not want to leave it as the square root of 50. I'd want to write it a little bit differently. And so that's what we're going to look at today. How would I take the square root of 50 and make it appear a little simpler? So we're going to talk about simplest radical form of square roots. Now, I said it's called simplifying, but sometimes they actually look more complicated than before you actually made them simpler, quote unquote. But the term is simplification, and we want to you need to be able to do it. So here are the two rules for simplifying a radical. The first is that when you have simplified it, the radical's going to have no factors, things that divide into it that are perfect square numbers. So that list we made on the previous page, except for 1, of course, because you can divide any number by 1, but no perfect square factors. The second thing that's important is you cannot have any square roots in the denominator. And so we use a trick to remove those. And so you cannot have a square root in the denominator. You cannot have any perfect square factors. So we're going to start off with some pretty simple examples. So for example, I was talking about the square root of 50. So what I want to do is I want to find the biggest number that goes into 50 that's a perfect square. If I cannot find one, then it's in simplest form already, and so I would be done. But if I'm talking about the square root of 50, I know that 25 goes into 50. And so I can rewrite this as the square root of 25 times 2. And we know from our rules of exponents, or radicals rather, that if I take the square root of 25 times 2, I can break it apart. And so this will be the square root of 25 times the square root of 2. I know the square root of 25, that's 5. And so my new way to write the square root of 50 is 5 times the square root of 2. And this is the simplified form. Now, there is an alternative way to think about this. I don't think it's any easier, but if you're having trouble with remembering the factors or finding it, maybe if you had a very large number, this might be a way to do it. And this way is the following. You can say 50, and then you break it into its prime factors with a factor tree. Well, that's 5 times 10, and then 5 is a prime number, so I've got that. I'm going to circle it, and then I have 10 is 5 times 2. And because I have these factors here, and the 5 is doubled here, so I have the 5 appears twice, so I have 5 and 5. That 5 is going to make the piece that's outside the radical. This 2, which is not a pair, is going to be inside the radical. And that's how I would do it in that method. So either method is fine. I think the one that I did in the yellow ink is more efficient, but certainly if you're stuck, that this second method can help you, because you just keep breaking the number down and down and down and look for factor pairs. Like here we had 5. So let's try another example. Let's look at the square root of 48. And so if I have 48, I know 16 goes into there, and 16 times 3. So the fast way to do it is to say, oh, well, that's 16 times 3. That's the square root of 16 times the square root of 3. And the square root of 16 I know is 4. So this would be 4 square root of 3. And 4 square root of 3 is the same as the square root of 48. Now, if I were doing it the other way, breaking it apart, I would say, oh, 48. Maybe you don't know what goes in there. You'd say 4 times 12. And it doesn't matter how you start breaking it apart. Just continue. 4 is 2 times 2. No, 2 is prime, so I'm going to circle that. And then I have 12. That's 2 times 6. 2 is prime. I'm going to circle that. And 6 is 2 times 3. And now I have it all broken apart. And if I look at for my factor pairs, I have 2 2's. So outside I'm going to have a 2. I also have 2 more 2's. So outside I'm going to have a 2. And then this 3 is all by itself, so it's in the radical. And so 2 times 2 is 4. This would be 4 square root of 3. Okay, so let's do one that's a little harder. Let's do the square root of 96. And I might look at 96 and I might say, gosh, I don't remember what the factors of 96 are, the perfect square factors. I know that 2 goes into there, and looks like 3 goes into there, so probably 6 would be something that would go in here. So I might take 96 and say, okay, I can break that apart, but I don't know 6 times what, so let's just do 3. So 96, 3, and it looks like that would be 32. And when I see 32, I can say, oh, 16. So 16 would have been a good choice for the perfect square. But let's keep breaking it apart. So I'm going to circle the 3 because that's a prime number. And 32, well, that's 8 times 4. So I'm going to do 4 times 8. And neither one of those is prime, but 4 is 2 times 2. So here I have a pair of 2's, and they're prime. 8 is going to be 4 times 2. So this will be 2. And then I'll have 4. And 4 is not prime, but that goes 2 and 2. So now I have it all broken apart. And so let's find the answer first. So I can take my perfect pairs here. So I have a pair of 2's and a pair of 2's. And so I'm going to have 2 times 2 on the outside, because I can take those out. And inside I'm going to have 3 times 2, because those are left over without pairs. And so I'm going to have 4 times the square root of 6. And that would be my answer. So this 96 is, or the square root of 96, which I should have had on here to find that. I guess I don't want to write it there though. So the square root of 96 is going to be equal to 4 square root of 6. All right, how would I have seen that over here? Well, if I was over here trying to do it more efficiently, I'd say, oh, I know that 16 is a factor of 96. And so 16 is going to be 16 times 6. And so this would be 16 times 6. And I would have the square root of 16 times the square root of 6, which is 4 square root of 6. And so I would see that 96 is the same as, square root of 96 is the same as 4 square root of 6. So you can see that depending on how good your multiplication is and what you see at the particular time, you might start with a different method. So I'd like you to try these in your own notebook and then see what you think. So we're going to start with 216. So pause the video and do 216. Okay, so hopefully you've done your problem, and I will show you how I would do this. So one thing I would say is you have to think of factors of 216. I happen to know that 6 goes into 216. So if I divide 6 into 216, notice the difference in the signs. This is my square root. This is I'm dividing here. So I'm going to have 6 into 21. That's 3 times, that's 18. And that's 3. And then 6 into 36, which is 6 times. And so it looks like 6 times 36, which is nice because 36 is a perfect square. And 6 does not have any perfect square factors. So I'm going to do it the faster way today for this one. I'm going to say 36 times 6. And so that's the square root of 36, square root of 6, and 6 square root of 6 is my answer. Now, if you were doing it another way, you might have said, well, I don't know what goes into 216, but it's an even number, right? So we might have said 216. I know 2 goes into there, so half of 216 is going to be 108. Well, now I know some things that go into 108. That's 9 times 12, right? So I can do 9 times 12, and this is going to be a 3 and a 3, so I better circle those. And this is going to be 4 times 3, so 3 times 4. 3 is a prime, and 4 is going to be 2 and 2. And then now what I have to do is identify pairs. So I have a pair of 2s, a pair of 3s, and that's it. So if I go to write this, I'm going to have the square root. On the inside, I'm going to have what's left over, the 2 and the 3. And outside, I'm going to have a 2 and a 3. And so it's going to be 6 square root of 6. So either way, you would get the same answer. So we've done some examples with finding the perfect squares and simplifying the expression. But there's a second rule, and this rule is kind of annoying but important, and that's that there are no radicals, no square roots in the denominators. Okay, so if I have an expression like 1 over the square root of 2, it's perfectly good mathematically, but it's not considered simplified. And so we don't allow you to write something like that as a final answer. And there are reasons for this, because if you do not simplify, you can two people can do the same problem and get answers that look totally different. And so that was why they had rules about how you would report your answer, so it was obvious whether it was you were getting the same answer or not. So how do we handle something like this? Well, we just use a trick. And so this is a pretty simple one. But the trick is this. I can multiply anything by the number 1, and it's not going to actually change the value. So I want this to stay the value of 1 divided by the square root of 2, but I want it to look differently. And so we do that by multiplying by 1. And so the trick is, I notice that if I take the square root of 2 times the square root of 2, I'm going to have the square root of 4, which is going to be a whole number, 2, because square root of 4 is 2. And so the trick is, you look at what's in the denominator, and you multiply by that. So I'm going to multiply by the square root of 2 on the bottom and the square root of 2 on the top, because this is really a value of 1, because square root of 2 divided by square root of 2 is 1. So it's a giant 1. And so there's no change to the actual answer except for the way it looks. So 1 times the square root of 2 is the square root of 2. And square root of 2 times the square root of 2, well, that's the square root of 4. So this is the square root of 2 over 2. And so this is the new way that this is going to look. They're equal to each other, but they look different. This is called the simplified form. This other one is just, well, whatever it was. So you try this one, 6 divided by the square root of 2. So pause the video and see what you get, and then we'll come back and do it together. All right, and so we're back. And so my trick, of course, is multiplying by 1, but the special one, it looks like whatever's the denominator is. So this is the denominator, square root of 2, square root of 2. So I have 6 square root of 2 on the numerator, and the denominator is going to be square root of 4, which is going to be 6 square root of 2 divided by 2. Now, hopefully, give yourself a star if you did this. If you have this, I'm going to be happy. But if you look at this, notice that 6 is divisible by 2. So this denominator here, 6 on top, 2 on the bottom, we can simplify that. So 6 divided by 2 is what? It's 3. And so your real answer should be 3 square root of 2. So this is what I will want for your answer, 3 square root of 2. But of course, I didn't show you how to simplify that, but I bet some of you did anyway. So that's our answer. All right, so let's do one more example. So what if I had something like 30 over the square root of 3? And if I want to simplify that, I just look at the denominator. So it's square root of 3. That's what I'm going to use to make my giant one, square root of 3 over square root of 3. And so 30 square root of 3 is going to be the numerator. And on the denominator is going to be the square root of 9, which is going to be 3. So you should be able to look at the square root of 3 times the square root of 3 and say, oh, that's going to be 3. Otherwise, you can do the multiplication in your head. Square root of 3 times the square root of 3 is the square root of 9, and then square root of that is 3. So now I have 30 divided by 3, so my final answer is going to be 30 divided by 3 is 10, and square root of 3. So I'm going to give you 4 problems, and I want you to do them and then check your answers. So I want you to find the square root of 720 simplified form, the square root of 3 over 16, the square root of the 10 divided by the square root of 2, and the square root of 45. So these are 4 different problems, and you should have 4 different answers. All right, the first one. So we're doing the square root of 720. I know 36 goes into 72, 36 times 2. So this is going to be, I'm going to break this apart. 720, I'm going to say, okay, 36, and that would be 20. But there's more perfect squares in there. So I know that, I know 20 goes into 4 and 5. And 5 is going to be a prime number that does not have a perfect square, but this is a perfect square here, 36, and 4 is also a perfect square. So I'm gonna kind of combine the two methods that we talked about. I'm gonna say, okay, well this would be 36 times 4 times 5. And so I have the square root of 36 times the square root of 4 times the square root of 5. And the square root of 36 is 6, square root of 4 is 2, and then I have the square root of 5 left over. So this is 12 square root of 5. So however you did that, hopefully that's what you got, 12 square root of 5. The second one, what you should notice about the second one is that it's got one radical over the top and the bottom, but you can split it up like this. Square root of 3 over the square root of 16. And so you can break up a radical in that way. And so the square root of 16 is 4. So this is just the square root of 3 over 4. And that would be our answer. Then we have 10 over the square root of 2. And remember, we don't like that radical in the denominator, so we're going to have to do some multiplication here. 10 square root of 2, and I'm going to multiply by giant 1 here. So on top I have 10 times the square root of 2. On the bottom I have the square root of 4. So this is 10 square root of 2. Square root of 4 is 2. And 10 divided by 2 is 5. So this will be 5 square root of 2. The last one, we have square root of 45. So I know 9 goes into that. So hopefully you said 9 times 5. So the square root of 9, square root of 5. That'll be 3 square root of 5. That's it. So hopefully you can complete your assignment using those as examples.